Hi guys, coming here. Welcome to my channel. Really excited to have you over here. Um, if you're someone who loves front-end engineering with React, or you love web scraping with Python, or just general data science with Python, you're gonna absolutely love my channel. And today I'm going to be doing something interesting with Ycombinator website. And this is the website over here, right? So I love data extraction. That's why I'm recording this video. So here we go to Y Combinator's website, right? Um, and as an analyst, right, I am an analyst, and very often I need to go to a website and say I need specific kinds of data, right? I don't want your HTML, I don't want your CSS, I don't want your JavaScript. I just want the data. But unfortunately, sometimes those websites don't come up with APIs that allow you extract that data conveniently, and that is why you'd have to resort to web scraping. So I am really excited to show you what web scraping is and how to use it. Web scraping is the act and the art of extracting structured data from unstructured sources. So this is an unstructured source, right? Even though they presented us with a table, at the end of the day, right? Like if I just need the name of the website, the company description, and the headquarters of the company, it still really adds together data just from the HTML page that has been provided to me. So that is where Python comes in. That is where Beautiful Soup comes in, and I am excited to show you that. Okay, so I've already prepared the code over here, and I have a mentality and an ideology and a philosophy that teach, teaching how to interact with code is not about coding along as much as understanding the true logic behind the step by step, understanding the logic behind each line. So I am going to introduce you to what I have done so far with scraping that data. So over here you can see an array, right? That an array, a list, or whatever you want to call it, based on your programming paradigm, right? But here's an array that has a bunch of objects or dictionaries if you are from Python. And those dictionaries have properties like name, overview, and URL, right? Because that's the data that I really need as an analyst. So I have written this elaborate script just to make sure that I don't have to copy this thing one by one, because that would be so tedious. That would be incredibly tedious. There are so many companies over here. There, um, yeah, 314 companies. Nobody really wants to do that work. That's ridiculous. So how do we do it with the power of Python? Power of Python. Here's what I've done over here. Okay, so what this first cell is doing. Oh wait, no, I have to tell you this. If you are starting a a project for the first time, you're probably going to have to install Python, right? And after you successfully install Python, you are going to be doing pip install request, right? Requirement already satisfied because I already have the request library. You are going to have to install Beautiful Soup and a bunch of other libraries, but that's not the crux of this particular video. So I'm just gonna leave that. And if you are using Jupyter Notebook, an alternative, you should do pip install request, right? Like the difference is that you're running this directly from the Jupyter notebook and you're putting an exclamation mark here. And if you are running from the command line, you are doing just pip install request directly. So we're not going to be doing that here because we already have the request and Beautiful library installed. So we're just going to have to import them. Okay, so let's start from the beginning. If I need to interact with this website, the Y Combinator's website, I am going to need to make a request to their website to get the data from their website. And in Python, what you use for that is the request library. So from over here, right, I'm importing request. This is what we are going to use to interact with Y Combinator's website and say, Y Combinator, give me your data. Y Combinator servers, give me your data. So I am doing that in a class because Python is a an object-oriented language. So sticking with OOP standards over here. So I've created a class that helps me get data from the internet anytime I want, right? And the reason why I've done that in a class over here and in a separate folder over here is so that I can call that anytime I want, right? Because the way that we interact with websites, the way that we call data from the Y Combinator's website, is exactly the same way we'll be calling data from Facebook's website. It's exactly the same way we're calling data from pretty much all kinds of websites. So that's why I have a class with a specific method about getting data from the internet. So I have a function over here called Tomide Beautiful Soup, right? And that function is a property of Tomide Beautiful Soup Utils. There's a function inside Tomide Beautiful Soup Utils, and that function accepts URL. What kind of website is it? Or is it a static website? Or is it um or is it a website that I'm going to have to, use Selenium to interact with? Let's leave that for another conversation. But this website we are interacting with is a static website. So the very first part of this function is all that is going to suffice for us. So we have terminated BS4 make soup. With and do not worry, I have a GitHub gist of pretty much all the code that you are going to need if you need to replicate this. So don't worry about that. Just understand the step-by-step logic. So I have a function inside the class over here. That function is called Tomide BS4 make soup, and that's the actual function that uses the request library to fetch the URL that we want to interact with. That's Y Combinator's URL, and it is going to return us something passed by Beautiful Soup. And Beautiful Soup just helps us convert the HTML. Like if you go to developer sources here, developer tools, and you find you find HTML over here, right? So it converts this document over here. Beautiful Soup converts that document. Beautiful Soup over here converts this document into something we can interact with, into something we can say, fetch me all the table rows, fetch me all the elements that have a class of top company rows, fetch me all the links, fetch me all the divs. That's what Beautiful Soup is doing. That's all it is really doing. So that's why I have a class over here that goes, if it's a static website, then I want you to use request to fetch all the content from that, and then I want you to use Beautiful Soup to pass it into a way I can interact with. And then I just want you to return that anytime I call this method inside this class. That's all I want you to. Okay, so now let's go back to our major script. In a little bit. Okay, so I'm saying the website I want to interact with Y Combinator. You all know that already. So I'm saying call the class Tomide Beautiful Soup, which I got from here. Call this class, and then call this method inside this class. What happens if I control click on this? Yes, it takes me right back to the method that I created, right? It takes me back to this method. So I'm saying call this class, call this method inside this class, and I want you to feed it this data exactly. I don't even have to declare target over here, right? Because target is the first thing, right? Like I'm just saying go directly to this website. And I'm saying the website is a static website, and you don't have to scroll, you don't have to scroll up and down. Just accept the URL, which is the target. Accept that it's a static website and run this condition alone. It's a scroll, so we're never even going to have to think of that condition. Okay, so do that. And then when we run Y Combinator top, what do you really think Y Combinator top is going to feed us back? If my assumptions are correct, it's going to give us an HTML page. It's going to give us exactly what we have here, right? This is exactly what it's going to give us. It's going to give us that URL back. So let's run that. So it's fetching the data in 3 seconds, 4 seconds. Yes, and it has the data exactly. right? In a text editor, we can view it better. Doc type HTML. The title is Ycombinator top company list. And I'm guessing if we go here and scrutinize that, we probably can find that. But I'm not going to go through that straight. Oh, yeah, I'm not going to go through that straight right now. Okay, but we have the data from, we have this, we have it inside our Python program, right? So what do we do next with it? So I have written another method called get classes. And the reason I have written get classes is because I realize that very often it's important to know all the classes that exist on the website, on the web page. I don't want to have to step by step go how many methods exist inside this particular element, like methods like company name, like sorry, how many classes, like classes like company name, classes like company website. That is so stressful. I want to know all the classes that exist at once so I can by myself figure out what to do next. So that's why I've written a method called get classes. Again, inside the class called Tomile Beautiful Subtil. So let's navigate to that. Let us split that right. Go back to our script. So what get classes doing? Get classes is a static method. And the reason it's a static method is because I don't want to have to give it the URL, the type, the scroll every time I need to call that method, every time I need to call this function. I don't want to do that. I just want to feed it an HTML page, and I want it to return all the classes in that HTML page. So I want it to return this. So I'm doing get all the tags on that page, find all the tags, find all the possible tags. So if the tag is a link, if the tag is a table data, if the class is a table row, just give me the tag. It doesn't matter the tag, just fetch me all the tags, and then return, put all those tags in here. So that means this is an array. The data type is an array. It's an array of all the tags that I find inside this web page. I hope not too confusing yet. Okay, so for all the tags inside this array, if the tag has an attribute of class, only if it has a class attribute, right? That's when I want you to return it. If it has an attribute of class, and if the length of the attribute of class is not equals to 0, right? Then I want you to proceed to this next condition of if um if it's not already in class list, right? If it's not already in this empty array, then I want you to push that class into this array. Push that class into this array. That's all I am doing over here. And at the end of the day, when you call this method, it's going to return you an array of all the classes that exist on this website. So classes like top company role, that is what is going to produce for you. So let us run that, and it successfully returns all the classes that exist. So next up we want to do is, so we already have all the classes, so we want to do Ycombinator top. Yeah, so from this HTML page that we have over here, we want to find all the table rows that have a class of top company. And if we go back to our developer tools, we realize there are elements that have a table row. There are elements that are table rows, and they have a class of top company rows. So we want to extract only this element. And how do we know these are the elements that we want to extract? Because if we over this and we do inspect, it brings us back to a table row, right? And these are the things that we want to extract across the entire web page. We want to extract all the table rows, right? So what I'm doing over here is find all the, okay, so I'm not going to need this again. So I'm saying find all the table rows with a class of top company row. Let us do that and see what it looks like. What do you really think it looks like? Let me ask that first. I'm guessing you think it's an array, right? It's an array that has all the top company rows, like an array that has Stripe, Instacart, Cruise, and more. But no, you'd be wrong to think that, because I'm using the find method over here instead of the find all, and the find just goes what's the very first example of it that exists, and the first example of table row table data of class top company row is Stripe. So it's just going to return this, and we can validate that by running this, and then we can see that it's returning data company ID Stripe. Everything here is about Stripe because it's only extracting this. It's only extracting this, and that's pretty simple at the end of the day. But we need that to validate that we are getting the right data. So the very next thing we do is, now that we know that if we run this, we will get the exact data we are looking for. So we're making a for loop that goes for all the elements inside Ycombinator top. Ycombinator top is the HTML page in itself. So for all the elements inside the HTML page, I want you to find everything that it's a table row, actually, not table data, a table row. So I want you to find all of this, and I want you to make sure they have a class of top company row. So make sure they have a class of top company row. So find all table row with top company row classes. That's what it's doing, right? So let's see. Let's confirm that first. Let's confirm that that works. So I want you to print everything that has the there is a tag of top row, of table row, and has a class of top company row. So let's run that. Oh, and it's a very long list. You know what? Here's another way to verify this, right? Let's go. I want you to um. Okay, yeah. Here's another way to verify this. I want Y combinator top dot find all of table row class top company row, right? But in this particular case, I want you to find the length of it. I want you to find how long is it really, and how long do you think it is. Give it a thought for a second, right? How long do you think it is? How many elements do you think exist inside Y combinator HTML page, table row, top company row class? How many elements? I am betting it's 314 or something like that. Let's see. I'm correct. 314 elements, and I mean it's 314 elements because if you scroll to the bottom of the page, scroll, you're going to find 314 elements. So that adds up logically. So let's delete this cell. We no longer need it. We've verified our assumption. So let's paste. Okay, so what we're doing here is we have an array, an empty array of companies, all the companies, like all Y Combinator companies, but an empty array, like there's nothing inside it. And we are saying if you find um an element with a tag of table row and a class of top company row, right? Then I want you to put that element into a dictionary, into an object, and that object will have a tag properties of name. And to define the name, I want you to go um inside the specific company, find all the a tags that have a class of company name and find the text inside them. And this is not really magical, right? Because if you go big O over here and you do inspect big O, it's an a tag with a class of company name, right? And this is what we're looking for. We're looking for just big O over here. This is really what we're looking for. So we're saying the name of the element, the object, the dictionary is inside company. find the first A tags you can see and look for a class of company name. And if inside table row you find the first A tag, right, and you look the first A tag that has a class of company name, you will see the name is big O, right? So that's how we want you to extract the name and convert it to text. Same thing with overview, right? If we do overview, inspect the overview, we're looking for table data. TD is a class of company overview, right? And we're looking for the text. So I'm doing company of find table data class of company overview, looking for the text. How about the URL? Like, hey, what's the URL of the I'm guessing that's over here. If you do inspect, that's the second A tag actually. We're looking for the href attributes of that A tag. So find A with a class of company website. Does it have the class of company website? Yes, it does. And I want you to get the attribute href, right? I want this is the attribute I want you to oh yeah, and it does that really, right? So if we can replicate that for just one element, we can replicate for the rest of the elements. So here is a simpler way of writing what I just did over here. Okay, company for company. Is that really necessary? Okay, no, I don't think it is. Okay, so I'm saying take this dictionary, take this object and put it inside, append it inside this company's array, this company's list, Python. That's all I'm really doing here. It's pretty simple at the end of the day. Looks kind of simple, right? So what I want to do is I really want, like, I know I have put all these elements inside this variable called company, inside this list, inside this array called company, but I want to see it. So that's why I'm doing company for company in company. And a simpler way of writing that, right, would be for each company, for company, or to be serious, right, like for each element. Let me delete all this. For each element in companies inside this array, for each element inside this array, this entire array, then maybe I want you to print the element. We have the 314 companies that we've extracted from Ycombinator, and I think that's the power of Beautiful Soup. That's the power of web scraping in general, being able to get really structured information from our structured data sources and being able to, in a sense, automate that. So that's why I'm really excited about web scraping, and I'm so excited that you joined me on this very short adventure. um Really excited to have you here. Thanks so much for joining my channel. I really appreciate your time, and please subscribe. Also follow me on all the media channels that are posted below. I will provide content on front-end engineering and on data science in general. Thank you so much.